I'm now streaming to YouTube Live. Apparently. Can't see my browser window either. Well, that is weird. So whatever I do, you can only see this part of the screen. Well, that's quite neat. If I make that smaller, you can still see that. That's quite neat as well. You can still only see that. It's only that part of that window. So not even that. So you're a bit behind. Stream is healthy. 0 watching. I don't want to see that there, do I? So I should be able to do that and that. And that. And then I can go over here and say do 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 do. Hello live stream. 0 viewers. Whoop. So I can webcast or YouTube live help sessions. Matt, I'm talking to myself. Oh, hang on. I've hidden the chat. Hang on a second. I don't need to type in the chat because you can hear me, right? Shouldn't you be doing physics revision? Ooh, maybe you can't hear me. Yeah, I could have been going for a long time, just writing random things to myself. Mostly just practicing my handwriting on this. I don't know if you've seen the new video, but it is pretty dire. Legit. Legit. Yeah, no doubt. Except you're watching YouTube. Except you're watching YouTube. Right. Oh, pretty dire. That is very good. Right, so I can get rid of that. Oh, we could do like speedy physics problems. We could do like if there's a cell and 2 resistors. what's V out? We've got an 8-volt cell and a 20 ohm resistor and a 30 ohm resistor. We could have speedy physics questions. I don't know if you can hear me or not. Excellent, you can hear me. This is a bit awkward because I didn't really intend for anybody to watch. 4 people are now watching. I don't know who those 4 people are. That's crazy, but I can see. And Solly's here as well. Oh, everybody's here. Isn't this exciting? Nobody's answered the question yet though. What's V out? I'm just waiting for somebody to get the answer. So 4 people are watching and 3 of them are talking in chat. Who's the 4th person? Can I see who the 4th person is? I should have an analytics window. It says watching now 4 people. You can view full analytics. Current viewers 4. Stream status good. Chat rate 4, 6 playbacks. Oh wow. Nobody has the answer. Do we need hints? I'm sure we don't need hints. We did this today. So V out is V in times R2 over R1 plus R2. Ooh. I thought you were doing revision, Harry. Come on, this is revision. Or we could play name the particle interaction. That would be fun, wouldn't it? Oh, one of those. One of those. Wiggly one of those. We could do name the particle interaction. 5 people. Gracious me. Harry's almost there. Right. No, we want this one. We'll save that one for later. Oh, Solly Varco with the 4.8 volts is the winner. So we've got 8 times by 30 over 50. It's 4.8 volts. It is just electron repulsion or electron-electron repulsion. Tick. Smiley face for all that's got it. You can take anyone as R2. So this is the one. That's the one you want. That's the one you want. So it doesn't matter if it's R1, R2. The numbers don't make a difference. It's just the one that you want. So we could do a slightly different one. I'll tell you what. I'll even do it this time with straight lines, I think. So if I hold down shift, I can do this. We can have straight lines. Wow. This is quite easily the most fun I've had all day. The other video was quite stressful. So I have one coming off there, one coming off there, V out. So let's say that this length here and this length here, I think I missed the shift key then. Say that was, I don't know, 80 centimeters, and that one there is, should we make it easy or hard? Somewhere in the mean, 40 centimeters. And then we've got so what we're going to find V out again, and then what would be useful? Let's have a 12-volt supply. Although that's a bit cheeky because they're both kind of add up to 12. So a slightly different equation this time, because we've got two lengths, but the ratio of length with the resistor. So if we know that resistance is resistivity times length over area, and as long as whatever this is, whether it's a wire or a strip or anything like that, as long as that is constant, then rho over A, all of that becomes a constant, so R is proportional to L. So our V out equation becomes V in times by the ratio of, I'm going to call it L2 just for convention, but we don't have to call it L2, we can call it whatever we want, L1 plus L2. There we go. Live physics question number 3. So we've got Solly's a winner, we've got Matt was a winner, and Solly's in there again. He's practicing his potential divider circuits hard. So in this case, you don't 100% need to use the equation, because here we've got this is 1/3 of a 120 centimeter strip. So this is 1/3, because our potential difference is split in proportion. Then we've got 1/3 of our voltage, or 1/3 of our potential difference out there. So we've got 1/3 of 12, which is 4 volts. Correct. I wish I could give you a prize. Can I give out prizes on YouTube? Is that a thing? What could we do? This is always a favourite. So how about if we had oh, this is going wrong. System of resistors that looks like that. Harry got 8 volts. Harry, did you do 8 over 12 or 80 centimeters over 120 centimeters rather than the 40? Because our V out was across the 40. Let's put another one there. Oh, see, I know these lines are straight because I'm holding down shift, but they're certainly not at right angles. And let's say all the resistance have resistance R. What is, I'm going to call it R EQ because I like calling it equivalent resistance. So that's R, that's R, that's R, that's R. What is the equivalent resistance? What is the equivalent resistance? So the first thing is to tackle this block here. We've got 3 identical resistors in parallel. What do we get? We get 3 equivalent resistors in parallel. What do we get? This is going to have to be my last one because it's 8 o'clock and that means putting children to bed. It is an exciting life. So what's the equivalent resistance of this entire block? just wait. We could do some practice. So in series, REQ equals R1 plus R2 all the way up to R plus anything up to Rn. 4 over 3R. Let's have a look. So in parallel, it almost sounds good, Mr. Fry, except that's a fraction. That's an irrational number. We're doing physics. Although, since we're doing it in terms of R, I'll give you that. So in parallel, REQ, or 1 over REQ, is 1 over R1 plus 1 over R2 plus dot 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 1 over Rn. In this case, we've got 3 identical resistors. So for this block, have I got another colour? Let's go here. I'm pretty happy with 4 over 3. So if that block there is a third of whatever one of these is, so that is 1/3 R, and then this block is in series with this one, so we add those together and that's R, so we get R plus 1/3 R, which is 1 1/3 R, so that's 3 over 3 R. We're going to add these fractions together, giving us a grand total of 4 over 3 R. Look at that. Isn't that beautiful? Well, it's been emotional. My first ever YouTube live stream. If it was fun, maybe I can actually think it through and not just start writing that I need to practice my handwriting, which I do, because look, it's awful. But I know how I feel when you all give me work to mark. Anyway, I have to go. I don't know how to stop streaming. Ha! I'll type goodbye and good night. How do I stop broadcasting? Well, this is embarrassing. Ah, Kyle! There you go. The secret watcher. Right. How did you get there? Oh, you're not in my class. I haven't even told you this exists yet. Oh, anybody want to tell me how to stop streaming? I could just close that window, couldn't I? That's a good idea. A stream recording is currently active. You sure you want to exit? Yes. Alright, next time, Kyle. Next time, Kyle, you'll be the winner. We'll see. Right, good night.